Hello and welcome to Module 5 of our API training. In this module we'll focus on using the external program plugin, abbreviated to EPP, and in particular we'll focus on using this within the operations interface. So our agenda will be to talk about what the EPP is and how it's triggered, how when it's triggered it can make command calls, and how parameters can be passed to it, which are dynamic tokens, and then as always some exercises to allow you to play with this yourself. So let's talk about what the external program plugin does and how it can be used. So we're writing scripts or programs to interact with the API, and some of those could be completely standalone in the sense that they're invoked by a scheduling system, but the vast majority of them will be invoked by a user running a process within the LIMS. So essentially we can have buttons configured at the process level which can invoke scripts, which they can be stored on the LIMS server themselves, or they can be stored throughout your facility, because the idea is that the EPP node can be installed multiple times wherever it needs to be. So as far as our little flow diagram here is concerned, the lab technician is using Clarity LIMS, and they click a button on a step or a process, and that obviously gives a message to the LIMS server, and the LIMS server will then find the appropriate EPP node which has that script, and the script will run. And chances are the script, it may produce a file, it may not. If it does produce a file, then the file will be automatically captured, stored in the LIMS server, and then available for the lab technician to use. So in its simplest form, the external program plugin acts as a bridge between something that's happening on the LIMS system and a script or a program which is typically running on an external system. And the way that you configure these external program plugin triggers is through the configuration side of the operations interface, and you would go in and modify the process and look at the 6th tab, the external program plugin. So the EPP can be triggered from any processes. So this includes configured processes, i.e. ones that you've crafted yourself from scratch, as well as the out-of-the-box ones, such as pooling samples, adding multiple reagents, etc. And where the EPP node is located, when the trigger runs, it's going to drop to a shell command line interpreter. So if you're on Windows, that'll be DOS. If you're on Linux or Unix, probably Bash. And it's that command line interpreter which is actually going to invoke the script. And another thing you'll see when you're configuring this is this concept of a channel name. So a channel name allows you to choose which EPP node is going to run your script, and rather than individually naming the EPP nodes, we can put those in logical groups which we call channels. So if you have the same script in 3 different places within your facility, then it might make sense to connect an EPP node to each place and put them in the same logical group and set the name of that logical group via the channel name. So let's take a look at a process which has already been configured to use the EPP. So I've gone into the operations interface, and chances are if you have your system prepared for next-gen sequencing, there's a number of processes in here that will interact with the EPP node. I'm going to choose one of the library normalization ones, and if we click modify and go to the 6th tab, external program plugins, we see a few things that are worth noting. First one is this checkbox to say that this process is associated with an external program, and it's associated via one or more of these process parameters. So let's modify and look at one of those. So we'll see in this case the channel name is defined as LIMS server. The parameter itself has a label which is create normalization CSV, and then we have the command line which is going to be executed on the node that the EPP is running on. So in this case it's calling bash and it's passing this command line, and you'll see that this command line contains this odd syntax where some of the things are wrapped in braces. So these are classed as parameters, and when the script runs they will be dynamically replaced with the real content that applies to the process that's actually being run. So let's talk more about those parameters. So when you're writing those command line strings that you want to be passed to the script, chances are you'll want some information which is not hard-coded but relies on an attribute or property of the process to which the trigger is attached. And we pass those pieces of information by means of these EPP parameters. So they're tokens defined in your command line string which pass values to a script when it's actually invoked. And if you were to right click on that interface when you're creating these strings or command lines, you'll see there's quite a list of them here, and incidentally you'll see this for real when I explain how the exercises can be completed. So there's a few important ones that as API scripters we need to understand, and this is the idea of these output file LUIDs. So there's a few illustrated here. Shared output files, the token name there is compound output file. And since a process can produce more than one of these, it's best to have an index, or in fact you must use an index here. So the first shared output file will be referred to as compound output file LUID 0, because we're 0 based here. If you have an output file that is not shared, so it has a one-to-one mapping with an input sample, then that one isn't a compound output, it's just a regular output file LUID. And once again you will need to specify an index here which is 0 based. And we can also pass, and you'll see an example of this in the exercises, values of user-defined fields. So custom fields that you've added to a process, they can also be passed to the script. So that's quite useful. So what are the exercises? So we will configure a process and we'll define two parameter strings or command strings that it will write. Very simple in this case, but they should at least begin to illustrate how this thing works. So the first one will just be writing hello world to a file, and then that file will be captured, and then the second one will be passing one of these user-defined fields. So we'll define one for color and we'll write that to the file and then capture the file.